Alright, so let's look at histograms. Alright, again we use this with univariate numerical data. There's a couple things. We got discrete data ways, so constructed differently than whenever you use continuous data. Alright, so you're going to draw a horizontal scale and mark it with possible values for the variable. Draw a vertical scale and mark it with frequency or relative frequency. Above each possible value, draw a rectangle centered at that value with its height, or with a height corresponding to frequency or relative frequency. Alright. For comparative histograms, use 2 or more separate graphs with the same scale on the horizontal axis. So again, if you want to compare things, you need to have multiple histograms, but you need to have the scale being exactly the same. So we're going to look at this one. Queen bees mate shortly after becoming adult. During a mating flight, the queen usually takes several partners collecting sperm that she will store and use throughout the rest of her life. Study on honeybees provided the following data on the number of partners for 30 queen bees. Alright, so we have all this data here. We're going to create a histogram for the number of partners of queen bees. So, first we're going to draw the horizontal axis scaled with possible values of the variable of interest. And then we're going to draw a vertical axis scaled with frequency or relative frequency. Then we're going to draw rectangles up to each one of the ones corresponding to the frequency. Okay, so notice how we end up getting 7 times that 7 occurred. We looked at our graph, our data, we ended up seeing that. Now, suppose instead we wanted to use relative frequency on the vertical axis. So again, you would take the number that times that occurred there over the total, and that would be your relative frequency. Alright, notice here we end up getting the relative frequency chart. So, what do you notice about the shapes of these two histograms? They're identical, just the vertical scale is different numbers. So it really doesn't make a difference if you use relative frequency or frequency whenever you're talking about histograms. You still will have the same picture, just different scale off to the side. So now we're going to talk about histograms with its continuous data. So again, we're going to mark the boundaries of the class intervals on the horizontal axis. Draw a vertical scale and mark it with a frequency or relative frequency. Draw a rectangle directly above each class interval with height corresponding to its frequency or relative frequency. So study examine the length of hours spent watching TV per day for a sample of children aged 1 and a sample of children aged 3. Below is comparative histograms. We have children aged 1 on the left, children aged 3 on the right. Alright, notice the common scale on the horizontal axis. Alright, so again, scale is the same on the horizontal axis, so you can compare the two. Alright, so when we're comparing it, the median number of hours spent watching was greater for the 1-year-olds than the 30-year-olds. The distribution for the 30-year-olds was more strongly skewed right than the distribution for the 1-year-olds, but the two distributions had similar ranges. So again, we talked about the center, the shape, and the spread for these ones, and you compared it using the correct data term. Now, we also will have histograms with unequal intervals. Right? So this is whenever you have a concentration of data in the middle with some extreme values. So this is something that will rarely happen, but you might end up seeing it. So how do you construct it? Construct similar to histograms with continuous data, but with a density on the vertical axis. So density is the relative frequency for the interval divided by the width of the interval. So it kind of just means how much is in that section, right? So density is a little bit different with working through it. So for this example, we use the queen bee data again. So actually, sorry, that was the wrong one. Now we're going to be talking about how we can use the histogram with a TI-83 or the TI-84. For this example, we will use the queen bee data again. So we're going to take all this data and we're going to put it in our stat table. So we hit stat and edit. It's going to pull up to this screen right here. So you'll see edit, we'll go into there. So you see the screen, you should be at the screen like this. After you've entered in all your numbers, you're going to then go to stat plots. So you hit second y equals. Right, when you do that, you get to a screen that looks like this. Okay. In a plot, you're going to select the histogram icon. So we enter the plot. The histogram one is the one that looks like the histogram, which is the ones that's the bars up and down. Alright, so you see the one that I have highlighted, that's the type that we will actually be looking for. Okay, so we're going to ensure that the X list is correct and the plot is on. So you notice we have the list one here and that one. Alright, if you need to change the list type second, then 1, 2, 3, 4, 5, or 6 based off of what list you actually put values in. Okay, for this one we'd had list 1, so we would hit second 1. Now make that list 1. Alright, after we've done this and you have everything turned on, you're going to hit zoom, then 9. Zoom 9 basically is going to make the graph look exactly what you need to on the screen. So zoom 9, so here's the zoom page. Notice that 9 says zoom stat. You hit that one. Then your graph will appear on the screen. Alright, so after your graph's appeared on the screen, we're going to have to go to a separate sheet of paper. We're going to create a vertical and a horizontal axis on that paper. Here's an example. Alright, we're going to roughly copy the graph. So here's our graph, and we just make a quick little rough sketch of that graph. Alright, we're going to then click trace on our calculator to get the information to label. So when we click trace, it pops up to here. Notice that it has like a minimum of 1 and a maximum of 2.833 with the values in there being 2. So we actually end up having that value that we can plug in. So put the low end at 1, the high end of that one at 2.833. Alright, so I like to have 4 significant digits with these whenever I'm doing it, but that one works perfectly fine. So we end up getting that set up there. And then just press right and continue on collecting the data. Notice now the minimum was the same as the one before. Now the maximum is 4.666. So 4.667 is what I'll put down here. Continue right. The maximum is now 6.5. That's what I'll put. Then max is 8.3. Put that there. Keep on working until we fill out all the ones that we know. Alright. So then we want to make sure that we end up having the horizontal bar being about right. So again, if we went back to here and we looked at the top one was 11. So we want the numbers to work out about right. Title and label the axis, and then you're basically going to be done with it. So once we title and label these axes, we've got now the queen bee life partners here, the frequencies on the left, the number of partners ends up being at the bottom, and we have our histogram all completed just by entering on the table on our calculator.